Hi everybody, I'm Chris O'Connor, Technical Director at Zerolight, and thanks for coming along to this presentation. So this is going to cover the development of a selection of our products and the challenges we faced for completing each solution and what the team did at Zerolight. And eventually, I'll get to the point of this talk as to why I now hate my railcar. So to start with, who are Zerolight and what do we do? So we basically create offline quality rendered graphics in real time. So our work can be viewed in Audi cities around the world, and it'll soon be available in many dealerships. Also, our configurator is available in the Pagani dealerships, for those of you that can afford a Pagani. And for the cheaper option, you can come along to our booth and experience the configurator in both Vive and VR. So this is a video of our creations, which there should be audio. So those are the sort of qualities we aim to reach for our customers. And Zerolight's going from strength to strength. Here are some of the awards, some of the press that we've managed to have. We only started the company 2 years ago. It started with about 5 developers, and now it's about 80 members of staff, and we're growing and growing. We work with many clients. Many of them you'll see over on our booth, mainly car manufacturers. There's many more coming in the pipeline that I can't announce yet. So a lot of the team comes from the games industry. We're used to getting every little last drop of power out of any hardware. So in the past, we'd developed for phones, we'd developed for the Chinese free-to-play market, and we'd developed for PS3. These are hard platforms to work on. We always get asked the question, and we always ask each other, why do people still have these devices? Why can't we have a little more RAM? Why can't we have a little more power? So this is an example of the graphics cards that we now use. So that's our minimum spec that we used to work on the free-to-play PC game. And this is the new Titan X's that we work with now. Obviously, you can see it's a massive jump in power, and everyone wants to work with the best, the latest graphics hardware. So, why do we choose Unity? So, our tech developers can concentrate on the new, exciting features. They don't have to spend time working on the core features like the FBX importing, the animation system, any of the control or anything like that. We can concentrate on R&D, generating new, exciting content. And really, when it comes down to it, it renders triangles, and that's what we need most. So it allows the quick R&D iteration process, and as I said before, the core features are already in place. And of course, it allows us to have very modular development. It means that when we have old code, we want to get rid of it. It's not bringing us down all the time. And it's very easy to use. So our artists, our programmers pick it up very easily. It's much easier than other engines that we've used in the past. and it means we can get creating brilliant work as soon as possible. So since the company started, we've had a whole range of projects. The first project was the Jaguar Land Rover showroom. So these were the specs that we was dealing with. Intel i7, 2 GeForce GTX 680s. We used a Connect and a 1080 display. So we was all thinking, this sounds like it's going to be easy. Like with them sort of specs, what problems are we going to have? And then this happened. So why does this happen? When we run in the editor, it was Unity 3.5 that we was using at this time. It was only a 32-bit application. We quickly ran out of memory. And then we'd get this, which was the drivers crashing all the time. And then everyone's favorite crash, this one, where the whole PC would die. So this made development very difficult in the early stages because we was dealing with such massive assets. So why does it crash so much? In Unity 3.5, the editor was just a 32-bit application. So where did all this memory go? That's a hell of a lot of memory to be using. The art team stole it. They always like to use lots of polygons. 3 million polygons, 3 gigabytes of textures, absolutely mental. For those working in games, those are mad numbers. So it was okay for the 64-bit release because then we had a lot of memory. We had big, powerful machines, and it was perfectly fine. But for the developers, it caused constant problems. So the solution, an easy solution, just beat the artists. Beat them until they cut down the models. Sadly, this didn't help. It only got worse. They put in more polygons, more detail, more issues for the developers. So we thought maybe we could limit the size of these models. While development, we don't need to see the end result. We don't need to see every single little detail in the system. So the built-in editor cut down of textures wasn't quite good enough for us. It didn't produce the right selective results. We didn't want to see everything really bad quality. We wanted to select, cut down certain things. So what we created was ZL Stream. So this was very easy to do. Plugins are great in Unity. It's very easy to write a C++ plugin, connect anything into the main code base, and the best thing is these plugins will work across updates of Unity, and you have no or very little conflicts. So we created simple header functions, passed through the textures, size that we wanted, and this allowed us to create a very simple streaming system. Of course, when you're working with plugins, make sure you call, if you're using multi-threaded rendering, make sure you call the render calls, anything you use the device from the device thread, which they have a very simple method using render thread callbacks. If you don't, you'll end up getting crashes all over the place. You won't know who to blame, and you won't know where they're coming from. So after this, everybody's happy. We reduced the overhead during development, and there was no more crashing. We could have faster iterations, and even the artists were happy. It's so easy to make a nice, simple interface, streaming textures, streaming data, and have the low quality in the editor and high quality in the release version. So all must be good. And then this happens. So what could possibly go wrong now? On the day of delivery of the build, getting ready to upload the 20 gigabyte package, we suddenly had a power cut. Why? Some people like cutting through power cables. This is an image I found on the internet. It's not actually what happened. I think I think really there was a few more flames, there was a couple of explosions, that sort of stuff. So what we got told was it will be back up in an hour. So we thought, we'll sit around, we'll wait, we'll wait a little longer. We'll wait a bit more. It'll be back up soon. We kept ringing the power company. When is it going to be up? All we need is one PC to upload this build, and then we can finally get it up to our clients. So we waited longer. And then we went to get the generator. All we need is one PC. You can use a mobile Wi-Fi, and then we can finally go home and we can get rid of this build for good. So here's a generator. Went and picked it up from the local DIY store. Started to start it up. Here's our CTO starting up the generator. So I thought, I'd stand back, take some pictures, enjoy this. And then I noticed, as I looked closer, what's this? Seems to be leaking petrol. Obviously, I stayed there, stood back a little, continued filming. For me, this would have been a hilarious video if it suddenly burst into flames, and it's an easy promotion for me. No work, him out the way, I've got a new job. Luckily, before it burst into flames or anybody got electrocuted, the power suddenly came back up, and we were able to complete this project. We was waiting around for about 8 hours, but in the end, it was all successful. And this is where we created the Jaguar F-Type experience. Using the Kinect, you could interact with the car, customize it, and see the car in the graphical quality that the client wanted. So these final results looked amazing at the time, and we knew there was great new things to come. So our next project, bigger, better, more of a challenge. But of course, we had new hardware. We worked with faster i7s, new Quadro K6000s at the time, but still had to run at 1080, and we had to run at 4K at 60 FPS. And of course, VR. So, second time round, it must be easier. It must be simpler. No, it's not. Never gets simpler, never gets easier. Nothing's ever easy. The artists all hate us. They always make it worse. What they decided to do was up the poly count from 3 million polys to 5 million polys. So these are created from the CAD data of the manufacturing CAD data of the cars. So we tessellate these up, and every detail is there. As you can see on this wireframe, every single number on the dial is modeled. It's a crazy amount of detail. Any renderer programmer would cry as soon as they see this model and never want to try and render this crazy amount of detail. But for us, we have to create that quality that the client expects. So it's all going to go fine. But then, all of a sudden, even with the streaming system, we had the memory crash again. There was just not enough memory in a 32-bit system to allow these sort of crazy polygon counts and crazy memory overheads. So this isn't the actual screenshot. At the time, we was all hitting our keyboards off each other, shouting about, getting very angry. But this is, someone else has the crash off the internet. But the solution wasn't too far away. Luckily for us, Unity 5 was just around the corner. This changed our world. It made everything much easier. It meant we could have the full graphics in the editor and experience our system as a whole as we developed it. So now, onto VR. This is one of our developers having fun in VR. So there's many issues with VR, but until you've worked with it as a developer, you don't really understand what those issues are. So for us, eye strain, big issue looking at them screens all the time. Sickness due to latency is always a problem. And really, the number one issue for us, and for many VR developers, is developer sweat. So these headsets, with the little sponge outlines, get very, very moist. They always get a wet feeling as you put it to your face, and you wonder, what's that? What's that? This feels so real. Like, I can't believe how good this VR is. It feels like there's a cool, wet breeze in my face. And then you realize it's from the previous person that was wearing the headset. So, more troubles with VR. So this is our developer, Matt, with the first kit. We thought we'd set up this classic shot, but we accidentally missed the fact that the PC is actually running Windows 10 in the background. So it's not actually a legacy screenshot, it's a rather modern one. So I'm going to go over some of the troubles: frame rate, anti-aliasing, latency. So frame rate. We'd managed to get up to 60 FPS rendering these crazy high poly model cars, and then VR comes along, and we get the Oculus DK1. We now have to render the car twice, and we still have to hit 60. Okay, that's not too bad. We'll manage that. And then DK2 comes along. We have to up the frame rate. And then the Oculus Rift comes along, and then the Vive, and we have to hit 90. Always a constant challenge. We were at the limits of what the graphics card could do. We were pretty much done every optimization we could think of, but that's where the more creative solutions come in, and you need to push it to the next level. So for us, profiling is always key. You always need to understand how your application runs. Very easy applications to use. GPA and Nsight are essential for tracking down when there are any issues. So in this case, we had an issue with batching. Obvious when it can be seen in Nsight. You can see how it breaks down the draw calls. We managed to get them batched together, and that pushed us to the next level to be able to render these high poly cars on these VR headsets. So it's sometimes just the little things can make a huge difference. So other frame rate problems we had. The 1 million poly bike on the roof rack was obviously a massive issue. It's not about the bikes on the roof rack, it's about the cars. So this was quickly tackled and cut down. But even since this point, we still get this sort of problem. I think on the Audi A8, they have a little wine rack in the back of the car, and in that it has champagne bottles, which were 200,000 poly each. So these cars are crazy. They have crazy detail in them, and it's important to our clients that we show all these details. So we do a lot of build time and mesh optimizations in order to get this data from crazy high poly count CAD data to real-time rendering solutions. Every shader instruction counts. We have to cut down every single shader, get as optimal as possible. Sometimes it seems like it may not be worth it, but every single nanosecond makes a difference in the end. And one of the more easy options is to reduce anti-aliasing. Dropping down that fill rate quickly improves your overall performance. So next, anti-aliasing. How do you make it better? Add more anti-aliasing. Of course, that becomes a problem because it's always a balance between quality and frame rate. The more you reduce anti-aliasing, the better frame rate you'll get, but the worse it'll look. And the more you up it, the worse it'll run. But there's loads of options out there. All these crazy letters, all these crazy things people have come up with. There's lots of options. They fit correctly for different setups. So on 4K, we'll use a different anti-alias type to what we use in the Vive and Oculus. It's best to just try them out, see what you can get, and see what the results are like. Also, try to tackle your anti-aliasing in the actual shaders themselves. This is massively cheaper and easier to do. There's a Valve paper that describes how to simply put this into your shaders. So then latency. Latency is a thing that makes everybody sick in VR. So I tried to search for an image on the internet for people being sick or looking sick, but it was just deprived content. So I thought I'd take my own image. This is the one I found. It's one of our developers, Luke. This makes me feel sick, so I thought it'd be perfect for this slide. So every VR developer knows that this is a big problem. You don't want your user feeling sick. You want them to enjoy the experience. So one of our big problems is SLI. Causes even more latency because we need that extra power to render these cars. It adds in extra frames of latency. And every single millisecond counts. So you should always completely profile your system, ensure that you've got no bottlenecks, no time wasted before you present that image to the display. So, of course, VR done right is amazing. And this is some of the guys in the Audi dealership choosing some cars, getting ready to buy and experience a brand new R8. So, of course, Audi revealed the VR experience will be rolling out later this year when they were at CES and GTC this year. And there's going to be a digital rollout towards the end of 2016. So I also got some of the images from these from the VR solution that we developed for Audi. So every single detail is modeled. You can get in very close, see all the fine quality. And of course, it's not just new cars. This is the 1938 Silver Arrow. This was, because we build our content by year, this one was quite unusual because we're used to working with 2015 and 2016 models, and this comes along and messes up our build system. But in the end, it's a beautiful car and a classic to explore and view the engine. So you can't actually purchase this car. This is more for just exploring and seeing what it looks like. So VR done wrong. So I've used my generic programmer model again, Luke. So here he is, playing about, hating VR. So I have no idea what Luke is really doing in these screenshots. I asked him to say, make VR look bad, pretend you're being sick. But he gave me these images. He gave me many other images. Got some of him in the sun, some of him enjoying a shower. I didn't include these in this, but anyway. So what are they trying to tell us? Our public is a general public. Our customer is a general public. We need to be really careful. What we want them to do is enjoy this experience and buy a car. If they have a bad experience, you lose a potential sale. Ideally, what we want is them to have a fun experience. If they enjoy that, they might go out and buy a VR headset. Best of all, they'll go out and buy a car. So not all problems we encounter involve crashing and being sick. There's many other technical issues working with the very latest technology. So I mentioned NVIDIA SLI before. It's a great system. It's pretty painless to start up and get running. But, of course, there are always problems. In FR mode, you'll get a lot of flickering. You have to make sure everything renders on each GPU because nothing is shared between them. In standard SLI mode, where data is shared, you'll get very bad frame rate. And of course, in VR, you get even worse latency. Luckily, NVIDIA have come up with a solution for VR, and that's GameWorks VR. Very simple to implement, very easy to use, and it knocks SLI latency pretty much in half. So another platform we deliver to is 4K. When we first started working on 4K, it was a massive issue getting these displays. We needed to find a display that would support 4K at 60 FPS. So at the time, we found one display, this massive display, impossible to ship. We had to drive it around Europe. We had to take it out to demos. And what we'd often do is give some of our artists a couple of euros, stick them in a rental car, put this in the back, and send them around Europe. That was often safer than traveling by plane, because taking one of these on the plane, you always get searched. You always get searched with VR headsets. People always wonder what these strange and weird contraptions are. So with 4K, we had to have our assets at even higher quality. We need to have finer detail in there. These pixels are so tiny, there's so much information in this display. And of course, this pushes the GPU to its limits even more. So yeah, always check the stats on your cables, because some cables will not support the bandwidth that's required. At the time that we got these, it was only DisplayPort. Not all graphics cards supported DisplayPort, and it was an absolute nightmare getting the correct combination of hardware in order to show our product at its best. And as I mentioned before, shipping to demos, absolute nightmare. But it's much easier now. It gets simpler. But even our 4K display we have on our booth, they couldn't find one in the Netherlands, and we had to ship that over. Luckily, it didn't crack on the way, but I have a feeling it might smash on the way home. Another issue we've got, or another issue we've had, is with 2 CPUs. So the machines we use are very high-end, and of course, when people are buying them, they think, 2 CPUs, this must be better. We must be able to hit higher frame rates if we have a second CPU in there. It's not always the case. More is not always better. What we found was having 2 CPUs caused a massive bottleneck in the PCI bus, which made the GPUs run much slower. It took us forever to track this down, and we was taking parts, swapping graphics cards out, until one day we decided just to try removing one of the CPUs and realized that it now ran much faster. But yeah, always make sure you test your hardware before purchasing a massive bulk load, or you'll end up with a cupboard full of spare CPUs. So back to Unity and what we do to Unity to make it even better, make the graphics as amazing as the image you'll see on this presentation and over at our Zerolight booth. So Unity gives us a great start. It enables us to quickly iterate, quickly test solutions. It has many features that are excellent, but we are aiming for the very top-end, high-end PC hardware, and we need to make sure that we're showing the very best, the very latest technology. So what we do is we just write our own. It's simple enough. We have our own shadows, we have our own lighting, we have our own PBR render technology, driving physics, asset system, light mapping, and VR plugins. Especially with VR plugins, we often get prototype technology, and we need to get it in as soon as possible. We need to try it out, test it, and view the experience in this new hardware. But with Unity, it's very simple to do this. Also in development, we use Jenkins. It ensures that you always have a very stable build. Obviously, it doesn't prevent people cutting through your power cable, but it removes human error from the development pipeline. So as soon as something goes wrong, we have these displays around the office. It highlights that something is wrong, and people fix it instantly. It's no longer the day before the milestone, and we suddenly realize that something might not quite be right and have to spend hours and hours trying to get the final build out the door. So I did another presentation yesterday which went into more detail about how to set up automated systems and how to set up builds so that you can avoid human error, you can do testing with ease, and not have to risk sending out incorrect builds or builds that are not the best solution to your clients. So, on to our next project. This is the Pagani showroom and VR solution. So, of course, again, we have even better hardware. So we're running faster i7s, Titan X's in SLI, and we still have to do 4K at 60 FPS and VR. So, a new challenge, but we always tackle it by optimizing and crafting our product to fit the new client. So with this new client, they wanted every single screw displaying. So this is one of the Pagani 1000 poly screws. So you can imagine how many of these there are in the car. And if you go to our demo booth and view the car and pull it apart, you can see how crazy this detail is. So as well, Mr. Pagani wants it to be perfect. Every single screw has the Pagani logo on it. For us, this isn't too much of an issue. It's a simple texture and can easily be solved. The real issue is the amount of detail, and the detail is very important. When you have a car this expensive, this much care and effort has gone into crafting and designing this model, the client wants it to look absolutely perfect. So of course, this puts a lot more pressure on the hardware. So, like I said, the cars are built to perfection in real life. We need to match in the virtual world. So, also, another way we use Unity is for the tablet configurators. So it's very easy to set up. Obviously, Unity is perfect for mobile devices. We create a tablet configurator, set up a simple socket connection to our server, and send messages across. That tells the visualization when to update and switch to the new cars. So here are some images of the Pagani that we render. As you can see, there's a crazy amount of detail in the engine. These cars cost about €1 million each. Usually, you have to put down a £100,000 deposit. You get to go in, sit down with Mr. Pagani, and customize your car. This is the Wyra BC. I think there was only 42 of these made. Of course, before it was even finished, the design, they had sold out. I think someone once said that this is the only car in the world that goes up in price. So people buy these second-hand, take them back to the Pagani factory, and get them customized again to suit their needs. So here are some more beautiful shots of the car. And here, with all the engine bays open, the doors open, looks like some crazy transformer. But it's a very nice and expensive car. So, in the end, why do I hate my real car? So, of course, as you can expect, sat in these virtual sports cars every day, it makes any other car look really bad. Like any other car looks poor in comparison to sitting in a Pagani, looking around the virtual cockpit, sitting in an Audi R8, experiencing the detail, the quality that these cars are manufactured to. So here we are. This is not actually my real car. Obviously, would be embarrassed to drive around in a car like that. This is our marketing executive's car. He likes to drive it into bollards and all sorts. But yeah, it was a struggle to find this car at Zerolight because everyone drives much nicer cars. But luckily, he just started. He had this poor car, and we could get this screenshot that represents the fun of VR compared to the real car in real life. So what's next for Zerolight? So we're constantly pushing graphical performance. So all of our screenshots, this is rendered in real time, 4K, 60 FPS. Everything is dynamic. You can turn the lights on, rotate the wheels, drive the car. In this case, it's a 5 million poly model, 100% customizable. Everything can be changed, paint color, alloys, interiors, and this allows our clients to set up the exact experience that they want to. So they can create virtual solutions, virtual showrooms, point of sale systems, and they can also use it for their marketing shots. So general marketing shots would take maybe a day to render using traditional ray tracing methods. What we allow them to do is set up the shots and get pretty high quality results within a matter of milliseconds. So this is our web-based visualization. So it's a car configurator that opens up in the web page. There's no plugins. It works in pretty much any browser. It uses a cloud system to stream a 3D interactive configurator to you. So this is currently live on Audi.de on the A4 All Road, and it has been said to be the world's best online configurator. I could do a whole talk about just our cloud solution and what we do and how we craft this product in order to make this solution that helps our clients to sell more and more cars and allows the customers to see the exact model that they're going to receive when purchasing a car. So what else is next for Zerolight? So we're continually developing the car physics integration, new driving sequences over varied terrain. A lot of our developers used to work on car racing games, so they have a lot of experience in how to create perfect physics solutions. The car manufacturers give us the physics data, and that car will drive how it drives in real life. Of course, we're always constantly doing more improvements to the lighting and shadowing, putting in new techniques, new methods to push it to that next visual quality level. Often our clients will come to us and show us an image, and they'll say, we want it to match this. And we'll look at it, and we'll be like, but that's ray trace. That took 4 hours to render. But still, they push us, and we come up with new methods, new solutions in order to get as close to that image as possible. So of course, to do that, we're forever optimizing. We're creating new VR experiences for a range of manufacturers. We've got new partners coming up, and of course, new cars and new content. And very soon, we're moving to new offices on the Gateshead quayside. So on the Newcastle quayside. So we're currently based in Gateshead, and we're moving over the river to Newcastle. So Newcastle is in the north of England. It's about 3 hours on the train from London, and the city is absolutely beautiful. It always looks like that when it's dark, of course. So if you want to know more about Zerolight, come and visit our booth. We're just out at booth 1 in the exhibition hall. We've been absolutely packed the last 2.5 days. People viewing our Vive experience, pulling apart the Pagani, throwing bits apart. We haven't had any accidents yet, so maybe this afternoon we'll also be lucky and no one will get injured. We also have the Gear VR solution, which is a cloud-based solution. It renders these super high polygon models up in the cloud and streams them down to the Gear VR. Obviously, the Gear VR isn't as powerful as 2 Titan X's in a desktop PC. So in order to deliver to our clients the best result, we've created this Gear VR solution, which is not like other solutions that you'll see out there. It is not just a sphere on a cube. It is a stereo experience, and it still looks 3D. And also, we have the 4K Pagani point-of-sale system where you can customize your Pagani, so come along and decide which Pagani you're going to buy, and then I'll pass on your details to Mr. Pagani, and you can go and order one. And of course, we're hiring. So we're looking for a range of experiences from junior to senior, graphics to cloud to programming in C++, C#, experience with Unity. If you want to be part of our award-winning, best-in-class team, then come along, talk to us, pass on your details. And that's it.